Good morning, everyone. Welcome to session 5 of the trainings of the Open Mode project. The name of this session is Commissioning of a Formex Raft. Welcome. I am going to divide this session in 9 small points, which are the transport of the element, the allocation of the floaters, the installation of the primary and secondary beams, the installation of the edge beams, the allocation of the formex or wooden joists, the floating of the structure, the towing of the structure, and a summary of the consumption of resources required to commission a raft. Well, we are going to start speaking about how to transport the elements of a formex or a wooden raft. Normally, the difference between using a traditional truck or a special truck is the maximum length of the beam transported, which is determined in 13.5 meters. So when the beam is longer than this, normally we need a special truck, as you can see in the picture of tester 1. If the beam is shorter, for example, tester 2 and tester 3, they have beams with 12 meters of length, a normal truck can be used. The consequences of using a normal truck is that it does not require any permit, so it is easier to carry out the transport, and also the costs are more economic. It is also relevant to say that in a normal truck, the maximum width is limited to 2.5 meters, but as our beams are linear, this is generally not a factor that conditions the transport. Finally, it is relevant to say that in a normal truck, the maximum weight of the elements is 24 tons, and that's a reason to limit in some of the rafts the weight of the structure to 20, 21, 22 tons. For example, tester 2 has a total weight between the floaters and the beam of 21 tons. So this means that it can be all transported in a normal truck. Well, the first step is to allocate the floaters in the assembling location. The floaters have generally a weight between 2 and 3 tons, and they are made of steel protected with glass fiber reinforced polyester. Normally we should allocate the floaters next to the water shore, because finally the assembly structure should be placed on the water, and we should place each floater on a wooden board to avoid the scrapping of the blue material, the polyester reinforced with glass. Normally, to allocate the floaters, we should measure the distance in both directions and also the distance between the diagonals. Well, once the floaters are stable and located in their final location, we need to place on them the primary beams. We have 4 primary beams, and we need to put them between the vertical bolts of the floaters. We need to be sure that the distance is the same in both sides, and we need to place on them the stainless steel plates, but not screwing the bolts. This is something we will do in the next step. Well, the next step is to place the secondary beams orthogonally on the primary beams. Normally we have 5 or 6 of them. Between the primary and the secondary beams, we have an intermediate neoprene to avoid that they scrap once against the other. To connect the secondary beams to the primary beams. To do so, we use a driller, which vertically will drill the synthetic pieces of both elements at the same time. Sometimes it's possible that these synthetic elements are not exactly one over the other, so we may use the chain with a crane to slightly move the primary beams, and then we will be able to place the synthetic elements one over the other and drill them, inserting a bolt to already screw and connect both elements. Doing this procedure that you can see in the upper picture in the right side, we are able to connect the primary and the secondary beams, and after this we can already screw the 16 stainless steel plates that connect the floaters to the primary beams. Well, and the last large beam that we install are the 2 edge beams that are supported on the 5 or 6 secondary beams. This is the last part, as all the grid is already connected. Normally, these edge beams, when we place them on the secondary beams, the synthetic elements to connect are already aligned one over the other. In both pictures, you can see the edge beams of tester 3 and tester 6 in Croatia and Denmark. You can see that they are exactly the same, because these 2 rafts are completely similar. Well, and finally, once we have all the grid connected and screwed, we need to install the joists on the secondary beams. This can be done with wooden joists or with Formex joists. In the end, the procedure is quite similar. We need to drill the joist and the secondary beam at the same time, nailing an element that has a diameter a little bit higher than the driller. So we drill with 8 millimeters and the nail has generally 10 millimeters. The use of one or other joist depends on the properties, conditions, and durability that is desired for the structure. In the case of the Formex raft, if we use a Formex joist, we will avoid any kind of maintenance and guarantee a longer lifetime for the structure. At the same time, installing Formex joists require certain type of equipment to move them because they are approximately 2 times heavier than the wooden joist. At the same time, the wooden joist has the disadvantage that the joist is not fully straight. So when we are hammering it, sometimes we need to force that one side of the stick moves to the final location and to nail it in this location. So somehow it's a little bit more risky to install a wooden joist than to install a Formex joist. Well, once the raft is already fully assembled, we need to float it in the water. So normally if it's a raft of 12 per 12 meters, 140 square meters, we need to rise it with a crane using 4 slings or from 4 points. In the video you can see an element that is a raft made of longitudinal tubes. It has approximately 21 tons of weight and we are using a 130-ton crane, which is admissible considering that the port is long and the crane can be located quite close to the raft and also to the water. Normally when the raft is larger, approximately 540 square meters, the crane that must be used it has a full capacity of 500 tons. This is normally used in places like, for example, Valencia or Sada, places where it is difficult to float it with a tidal range or where there is not so much tidal range to use it to float the structure. In Galicia, generally, this tidal range allows that we assemble a structure in a ramp. So we install it when the tidal range is low, and when the tide comes, if the structure is already fully assembled, it can be directly towed, not using a crane. Here in this slide you can appreciate 2 pictures of 2 rafts. The one from the left is a 140 square meters raft, a Formex raft with wooden joists floated with a 130-ton crane. In the right side you can see a 540 square meter installed in Valencia. This is the maximum size admissible for rafts and which is being floated with a 500 tons crane. In this case, we need to rise the element using 6 slings. Well, in this case, 12 slings, but rising from 6 points, from the 6 floaters. And finally, regarding the towing of the structure from the floating location to the mooring location, normally the power that we require to tow the raft is very reduced, particularly if we don't have any adverse environmental conditions. So in the upper picture in the right side you can see a small raft of 140 square meters, how it is being towed with a really small boat. This is the tester number 3. And in the bottom picture in the left side you can see a much larger raft installed in Valencia, which is also being towed by a really small boat at a slow speed, but nothing larger is required. So to conclude, I'd like to summarize the consumption of resources to install a small and a large raft. In the case of the small raft with 140 square meters, we may use only normal transport to bring the beams and the floaters. We need approximately 2 or 3 employees to assemble the raft, and in the case of the rafts with 4 floaters, we will need approximately 1.5 days to assemble the structure. In the case of using 2 tubes, the maximum time that we will use is 1 day, including the allocation on the water. If we use the same crane for the assembling and also the floating, we will reduce this maximum period of assembling. In this case, the yearly production of shellfish is approximately 25 tons. In the case of the larger rafts with 540 square meters, normally we require 4 or 5 employees to assemble it during 3 days. and we can use the tidal range to install this structure. The maximum yearly production of it is approximately 100 or 120 tons of mussel. And this is everything from our side. Thank you for attending to session 5, commissioning of a Formex raft. I hope we can meet again in session 6.